Let's say I have a right triangle like that, and I rotate this right triangle about this particular axis, and that would give me this shape. This figure, this 3D figure, as we all know, is called a cone. Cutting this figure in various different shapes would give us 4 different very interesting types of shapes, and this gave rise to a new topic called conic sections. The 4 different types of conic sections are the circle, the ellipse, the parabola, and the hyperbola. And these 4 different shapes are formed when we cut the cone in different ways. Let's get some terms sorted before we move on to how the 4 shapes are formed. The hypotenuse of the right triangle, which contributed to make the cone, is called the generatrix or the generator. And conic sections are generally formed by a double napped cone. In case you're wondering what that means, it's very simple. It just means this double napped, and this particular section of the double napped cone is called the upper nap, and this section is called the lower nap. And this particular angle alpha is the angle that the generatrix makes with the axis of the cone. This particular figure on the cone, as we all know, on the base of the cone rather, is just a simple circle, the humble circle. It can be formed by cutting the cone using a plane in any way, at any distance from the vertex. The vertex, by the way, is this point, such that the plane makes a 90-degree angle with the axis. The equation of the circle is given by x square plus y square equal to r square. I'll be explaining that in my circle video. The ellipse is also formed in a way that's very similar to the circle. If we take a plane that's like this at an angle to the axis, let's define this angle more properly. Let's call this angle beta. This angle is called beta. This angle, as we all remember, is called alpha. What I do is, if I cut the cone in such a way that alpha is less than beta, which is obviously less than 90, then the shape that I get over here, this section over there, would not form a circle. What it would form is a very different shape, which is the ellipse. The equation of this ellipse is given by x square by a square plus y square by b square equals 1. Circle is a special case of ellipse, and it can be seen that x square by r square plus y square by r square equals 1, which is just similar to the ellipse equation. From this it can be known that the circle is related to the ellipse, or rather the circle is a special case of the ellipse. Moving on, we have the parabola. The parabola is a very different kind of shape. We get a parabola if we cut the cone in such a way that our beta this time exactly equals the alpha. When beta equals alpha, we get a shape that's like this. And the equation of a parabola, the general equation, one of the general equations, is given by y square equals 4ax. Finally, I'll need a double napped cone for this, so I'll just remove this. So let's say I have this double napped cone, and my plane this time cuts this cone like this. Such a way that the angle beta is less than the angle alpha, and the angle beta shouldn't be 0. If it's 0, it's a special degenerate case which I'll be coming to later. This forms a hyperbola, and the general equation of the hyperbola is given by x square by a square minus y square by b square equals 1. So these are the 4 conic sections, and these are their 4 equations. I've shown you how they formed. Now I'll show you some special degenerate cases of conic sections. The first case produces a very simple result. What if my plane cuts the double napped cone at the vertex? It's very simple. I just get a point. And if my plane happens to cut the generator or the generatrix, it's just a single straight line that's formed, and this straight line is actually the degenerated case of the parabola, as the angle beta that our cone makes with respect to the axis. If I just draw a line like that parallel to the axis, this angle is beta, and this angle is alpha. We can see that this angle would also be alpha, and by alternate angles property we know that beta will be equal to alpha. So this particular straight line is a degenerated case of the parabola, and this degenerated case where my plane passes through the vertex, and in such a way that the angle beta is less than the angle alpha. It's supposed to be a hyperbola, but then because it passes at the vertex, it does this instead. And this. That's my vertex, and to the cone over there. What it does is it gives me a pair of straight lines which have a common point at the vertex. These are the 3 degenerated conic sections. I'll be covering all of the rest of the 4 conic sections in detail in my coming videos.